Hello everyone, welcome back to agronomy series. So we have till now we have already covered introduction to agronomy, agrometrology, soil and tillage. Okay, so today we will discuss about soil and water conservation. So why soil and water conservation is needed? Because soil and waters, they are already natural resources, and we have to conserve them to get sustainable productivity, right? So what is soil erosion in your viewpoint? Okay, soil erosion is basically detachment of falling raindrop, detachment of particles, of soil particles due to falling raindrop, channel flow or wind, and then transportation of these particles by the help of water, rain splash or wind. Okay, so basically soil erosion is detachment and transportation of particles. Okay, so extent of soil erosion, we have water erosion in India. Water erosion is extended up to 45%. Around 148.2 million hectare is subjected to water erosion, and wind erosion is about 4.1%, around 13.5 million hectare. So in India, more than 5,000 metric ton of topsoil erosion occurs every year, and around 1600 metric ton, around 30% of that quantity permanently move to sea. Okay, permanently we are losing that soil. Okay, so extent of soil loss in India is about 4.8 million ton per hectare per year. Who is the scientist who first studied scientifically about soil erosion control? The scientist was Olney. He was a German scientist, soil scientist. Okay, then lead in soil erosion research by USA Forest Service during 1915-1917. Then 10 research center in USA was established by Bennett during 1928 to 1933. Soil conservation research in India started in 1923 at Dry Farming Research Center at Manjri near Pune. 8 centers of ICR merged, merged to form CSWCRTI, Central Soil and Water Conservation Research Technology Institution in Dehradun during 1st April 1974. Again, AICRP Dryland Agriculture merged to form CRIDA, Central Research Institute for Dryland Agriculture, in 1985 at Hyderabad. Then Kajri Central Arid Zone Research Institute established in 1959 at Jodhpur. What are the types of erosion? Broadly, erosion is divided into 2 types: geological or natural or normal erosion, that is undisturbed by biotic factors, and it is slow and self-healing. Then another one is accelerated erosion, that is anthropogenic or man-made, that is rapid. Okay, then based on the transporting agent, we have 2 types of erosion: water erosion and wind erosion. So water erosion is basically different kinds of water erosion are there, like splash erosion, seat erosion, reel erosion, gully erosion, ravine erosion, landslides, stream banks. These are water erosion forms. Okay, so detachment is by erosive hydrodynamic force of rainfall. Do you know what is the force exerted by these rainfalls? If the rainfall size is 5 cm per hour, if the rainfall intensity is 5 cm per hour, then the force is 5.6 kilowatt per hectare. Okay, and if the size of intensity of the rainfall, that is 7.5 centimeter per hour, then the force will be exerted as 520 kilowatt per hectare. Okay. So can you imagine this force? This force is actually detaching the soil particle. Then what are the factors factors affecting water erosion? So these factors are rainfall erosivity, soil erodibility factor, topographical factor, length of slope factor, soil cover factor, then biotic interference. Okay, then estimation of soil loss due to water erosion. United States USLE universal soil loss equation. This was developed by Westmere and Smith in 1959. So the equation is A is equal to RKLSCP. Okay, so these are the factors actually. RKLSCP, these are the factors. As I discussed, that soil erosivity, rainfall erosivity factor, soil erodibility factor, topography, length, So the soil erodibility factor is inversely proportional to infiltration rate. Suppose a soil is having high infiltration rate, then the soil erodibility factor will be less there. No. So what is wind erosion? Wind erosion, the transporting agent is here is wind. So the extent is 33 million hectare. In desert area it is 23.49 million hectare, and coastal sand 6.5 million hectare. So minimum fluid threshold velocity is the velocity above which wind actually can detach and transport that soil particle. So for 0.1 mm diameter soil particle, the minimum threshold fluid velocity is 16 km per hour. What are the stages or forms of wind erosion? That are saltation, suspension, and surface creep. In saltation, the sized particle that is carried by wind is 0.1 to 0.5 mm, and the extent of saltation is highest, that is 50 to 70%. Then in suspension, the particle size less than 0.1 mm diameter is transported, and the extension is like 15%. Then the surface creep, the particle size here carried is 0.5 to 2 mm diameter, and the extent is 5 to 25%. So what is the equation that can estimate the erosion, wind erosion? E is equal to IRK FC WdV. Here I is the soil cloudiness factor, K is the surface roughness factor. There in water erosion, that USLE, K was the soil erodibility factor. Here in wind erosion, surface roughness factor is the K. B is the wind barrier factor. Okay, factors affecting wind erosion are soil cloudiness, soil roughness, water stable aggregates and surface crust, wind and soil moisture, field length, vegetation cover, organic matter, topography, and soil. Soil conservation. So to prevent this erosion, we have certain conservation measures. So what is soil conservation? Managing the land based on the capability and application of best management practices leading to profitable crop production without land degradation. This is soil conservation. Again I am repeating, managing the land based on capability and application of best management practices leading to profitable crop production without land degradation. This is soil conservation. Land must be used according to land capability classification. You know, there are several land capabilities, like 8 kinds of land capability classification. Based on those land capability classification, based on those recommendations, we have to use the soil. Then what is the principles of soil conservation? Maintenance of soil infiltration capacity, soil protection from rainfall, control surface runoff, safe disposal of surface runoff. These are the principles of soil conservation. Okay, so what are the components? All these components like agronomic measures, mechanical measures, forest or agrostological measures, these are complementary to each other. No, not a single measures. Like suppose we want to prevent the soil erosion, and we cannot use a single measure to prevent it efficiently. So all these measures are complementary. Okay, so agronomy measures are choice of crops, land preparation, strip cropping, mulching, organic matter, fertilizer application, cropping system, cover crop, etc. So where agronomic measures are generally used when the land slope is less than 2%. Then mechanical measures, when the land slope is more than 2%, then mechanical measures are generally adopted. What are the mechanical measures? Contour bunding, if the rainfall is less than 600 mm and the slope is less than 6%, contour bunding is generally used. Graded bunding, when rainfall is more than 600 mm. Contour trenching and bench terracing. Bench terracing generally used in higher slope area, that is 16 to 33%. So bench terracing again divided into slope outward bench terracing, sloping inward bench terracing, tabletop bench terracing, then Puerto Rico bench terracing. Okay, so then forest and grasses. Using forest and grasses, we can even conserve the soil. That is known as agrostological measures. So what are the tree species on grasses species we generally use? Acacia, Leucaena, Eucalyptus, Vetiver, Cencros. These are the grasses, and these are the trees. Acacia, Leucaena, Eucalyptus. These are the trees we use generally to conserve the soil. So wind erosion, for wind erosion control, the principles are: we have to reduce the wind velocity, we have to increase the soil aggregate size, we have to trap saltating soil, we have to keep the soil moist to prevent wind erosion. Okay, so what are the practices? Stubble mulch or minimum tillage, cover cropping, strip cropping, crop rotation, mulching, wind break and shelter bed. These are the practices we follow to prevent wind erosion. Okay, so what are the general questions generally asked in entrance examination? Some of the questions I am going to discuss. So what contour cultivation is done along the slope or across the slope? Contour cultivation always done across the slope of the field. Okay, what is agrostology? Study of grasses is known as agrostology. Area under shifting cultivation in India, that is around 6.7 million hectare. Area affected by wind erosion in India, around 10.46 million hectare. Soil erodibility factor maximum for clay soil. As we have discussed, soil erodibility is inversely proportional to the infiltration capacity. Okay, so initial stage of water erosion is seat erosion, that is removal of uniform thin layer. Dead furrow are formed at spacing of, what is the spacing maintained in the, between dead furrow? 3.6 meter. Scientific name of Guatemala grass, that is Tripsacum laxum. Movement of soil particles as series of joms. When the soil particles are moved in series of joms, that is known as saltation. That process is known as saltation, that is 50 to 70%, and the particle size is 0.1 to 0.5 mm. Inverted contour winding is otherwise known as conservation ditching. Masonry check dams control gully erosion, and as well as it is used in water harvesting. Extremely high category of wind erosion is having wind erosive index. Wind erosion index, extremely high category of wind erosion is having wind erosion index is more than 480. Best serve nutrient pumps in soil having hairpin is trees. Okay, best serve nutrient pump in soil having hairpin is trees. The land category where cropping is possible only after recession of flood in eastern India, that is known as diarrheal land. World Bank funded IWDP started in 1991. NWDPRA started in 1986. Hanumant Rao along with FAO agencies prepared the new concept of four water, which include rainwater, surface water, groundwater and soil water. Okay, Hanumant Rao, remember. Capacity of erosion causing agent is known as erosivity, that is rainfall erosivity, right? Susceptibility of soil to erosion known as erodibility. The symbol is K. The value varies from 0 to 0.6. Compaction increases soil erodibility. Okay, estimated soil loss due to erosion is about 16.35 ton per hectare in India. Zinc terracing generally followed in slope 3 to 10%. Wave erosion is the combination of wind and water erosion. Size of micro watershed, that is varies from 100 to 1000 hectare. Example of watershed modeling, that is black box model. Black box model is for watershed modeling. Okay, so this is all about soil and water conservation. So stay tuned guys for my other lectures. And if I have not gone through my previous lecture, just watch them or listen them and make note out of them. Okay, do not listen and forget. Make notes out of them and you just listen again and again. Okay, so that you can recall during the exam time. Thank you.